Okay, so don't forget this Thursday we will have quiz, and also I think some of you requesting for the when is the midterm, right? I think we can have the midterm. How about 19, 19, 19, November 19, November 19. The schedule for from the school is actually from 9 of November, the week midterm, right? The midterm weeks. But I moved to week after that, 1 week after that, so 19. Because I think the other course you have will be on that week, right? Okay. So 19, is it okay for your midterm 19? If you follow the school, it should be earlier. You want early? You need to choose. Okay. So I give you 1 week after. Okay, 1 week after. Okay. So 19 Thursday, 19 November. Okay. Okay. So for today, uh, I will reviewing chapter 4 a little bit, and then we can review chapter 3 for your quiz, okay, for preparation. Okay. Now look at this graph. Okay. So the question is just asking when the function is increasing and decreasing, and what is the local max or maybe min, and you need to figure out which one is local max, local min. No need to check the value of max and min, just check which x. So there's only two questions: finding the increasing, decreasing, and finding the x that makes the graph have max or min. Okay. So we have two graphs. First is this graph, and the second one is this graph. So let's start with the first one. Okay, let's start with the first one. You need to read carefully. Okay, you need to read carefully. This is f prime, not f. Okay, I'm giving you a couple minutes to write down your answers. So I think I'm giving you both graphs. Okay. 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 Both graphs here, they both f prime. They both f prime. Okay. Still chapter 4. Yeah. I think one more section and we move to chapter 5. Yeah. Okay. 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 So when is the function increasing? Okay. From the first case, when the function increasing? 1 to 5. Yeah, good. And decreasing 0 to 1 and 5 to 6. Okay. Okay. Anyone disagree with that? Anyone disagree? No, right? Okay. Okay. So remember, okay, again, this is f prime. Okay. What you need to do is just remember, okay, when you have f prime, if you have f prime greater 0, okay, this means increasing, okay, or maybe I'll write in the correct. So this f increasing. So f prime less 0, f decreasing. Okay. So from here, from this graph, you see this is positive, this is negative, right? This is positive, this is negative. Okay. So f prime greater 0, so from 1 to 5 is all increasing. So f increasing is 1, 5, and f decreasing zero, 1. Okay. To write increasing, decreasing, I'm suggesting just using open bracket. Okay? Do not have the closed bracket because we don't really know what the function are, right? Just to make sure. Because it's asking just region where the function increasing or decreasing. Okay, that's increasing, decreasing. And how about max and min? Okay, so we have increasing, decreasing. Okay. To check whether it is max or min, we need to figure out where the f prime is 0, right? F prime 0 are 1 and 5, right? So in, let me write at x equal 1, okay? At x equal 1, you see the change is from negative to positive, right? It is from negative, positive, right? So it's going down and going up. So if you get this, then it's minimum, okay? So this will be min. And at x equal 5, see 5, 5 is here. So it's from positive to negative, right? So it's going up and then down. And from this conclusion, we get this is the maximum point. So minimum point at x equal 1 and maximum at x equal 5. Yeah, also. Also, you can also think at the end point, but we don't really sure about the graph what the graph looks like. So we can just ignore the endpoint. Yeah, okay. Okay, now let's see the second graph. It's the same f prime. It's not f, but f prime. Okay. So this is positive, negative. So of course, check when you are having positive region, this will be increasing. And the whole thing here, and maybe here, is decreasing. Okay. So f increasing at 0, 1, and then 5 to 7. And f decreasing 1, 5, and 7, 8. And then max and min, we see we have at least 3 from here. So x equal 1. It's from positive to negative. So you can see it's going up and then down. So maybe this is max at x equal 5. It's from negative to positive. So it's min. And at x equals 7, it's from positive to negative. It's also max. And we don't need to know whether it's absolute, local. We just write its maximum and minimum. That's fine. Okay. Unless they give more information about the graphs, then we can make sure about how maximum it is. The max min uh, by this question, it means the graph behavior. They are going up and then down, or going down and then up. Okay. Okay, that's a little bit review, and also I want uh, to 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 review how to sketch a graph. Okay. So if you have this function, 1 over x squared, 1 over x minus 1, and then squared, it's not easy to graph, even when you derive and you need to find the critical point and inflection point. It's not easy to graph. But you still can, with certain skills, you can still get information from this graph. Okay. The only thing that you can notice is always see the functions in its domain. Okay? Where the domain, you see it having 1 over x. So x, obviously it cannot be 0, right? And x minus 1, so x also cannot be 1. So you can have, or you can write here, you can have domain, all x, but except the uh, 0 and except the 1. And these 2 points, 0 and 1, it may become the asymptote of the graph. Okay. So maybe it will be a vertical asymptote, and we can also check later. And if you want, you can also check the intercept, because we cannot have x equals 0. Maybe we will have y equals 0. Then we can check if f of x is 0. Then we can have, or let me solve this one first. Okay, let me solve this I will write this directly. Okay, minus 2x plus 1 from this expansion, and then the thing that makes all 0 is only this negative 2x plus 1. Okay, and we get x is half. So at half 0, we will have an intercept. So the curve will go to this point. It will cross this point. And then checking the asymptote. Asymptote means you need to check with your limit. First, checking the limit as going to infinite. Okay. We can separate these two to make it easy to observe. So first is this, and second, maybe we need to expand so we can see clearly. So this will be 0. And this also, if you check, divide by the highest degree, you will get also 0 here. Okay. It will be 0. So y equals 0 is our horizontal asymptote. And then based on our domain, we can check those 2 points with limit. Okay. For these two, each one you can check from left or from right. Okay. So maybe 0, you can check from left. Maybe you can have negative 0.1 or negative 0.2, any number that you can find easily. And you can think what will happen with the value. Okay. And then check the other number. And maybe first you can check negative 0.2 and negative 0.1. And you check whether the curve going up or going down. And then you will have a conclusion that this limit x approach 0 will be positive infinite, and 1 will be negative infinite. Okay, you need to check from left, from right. Okay, you need to check both sides. Okay, and then we can compute our g prime. So these separate equations we can differentiate separately. Okay, so first derive the 1 over x squared. Okay, you will get negative 2 over x cubed, right? And same thing here, differentiate, and you will get, because it's negative, it's become positive 2. Because it's only x minus a constant, then that should be only 1. Okay, now we have this g prime. Okay. Okay. Then we can check the g prime, or we can write g prime test. first, maybe we solve this, and maybe we need to find when g prime is 0, is there any x that fit our equation? So let's try g prime equals 0. Okay, I get this g prime that's equaling 0. Can we solve this? I think it's always positive, right? Do you think it's always positive? If you think it's always positive, you can write it's always positive if you think. But if you want to try to expand x minus 1 cube, you can also try and make a conclusion. Let's just try to expand this. Let me copy first. Okay. The coefficient for cube, you remember, it will be 1, 3, 3, 1, right? This will be cube, this a squared b, ab squared b cubed, right? So let me write 2x cubed first, and then minus 2x cubed minus 3x squared plus 3x plus 1. Oh, not plus. It should be minus. It's cube. Okay, sorry. Okay, now this part is cancelled. I will just see the top equation. Okay, this is only the top equation. Let me solve this. 6x squared minus 6x plus 2. That's equaling 0. Okay. If you remember the quadratic formula, you can check this. Yeah, check the, we say this is the determinant. Okay, so if you check b squared, it's 36 minus 4, 4, 6, 24, 2, 48. 36 minus 48. It's negative, right? Which means we can write there is no real solution. Which means the curve will be not having any critical point. Okay, so there is no critical point. But we still can figure when the function is increasing or decreasing. Okay. Let me copy our g prime from here. Okay. So there's no critical point, and we still need to check. Okay. So checking g prime. How to check our g prime if we don't have critical point, how we check the G prime? We can try any number, but then we will lost in track, right? How we check the G prime? We don't have critical point. Usually we get critical point, we check the critical point, right? Before and after critical point, but we don't have critical point. What should we do now? But we still need to check the G prime. We need to check whether the function is increasing or decreasing. How we check the G prime? Any idea? We don't have critical point. How do we check the G prime? Any idea? Any idea? Any idea how to check? Any idea how to check? No? Yeah, we can check random point, but you will be lost in track if you're just checking random numbers, try point by point, and then okay, you will get lost. So the easiest way to check your f prime or check your first derivative, okay? You have these two vertical asymptotes, right? You have vertical asymptote at 0 and 1. That's the easiest point that you can check. Okay? Of course, x should not be 0 and 1, but we need to check number nearby that point, right? So let's check the asymptote. Our asymptote is 0 and 1. Okay? Because imagine at 0 and 1, you have a long line, vertical line, right? But your curve is less than 0, in between 0, 1, and after 1, right? So you can check whether the function is increasing or decreasing by putting some number around this 0 and 1. Okay, check maybe -1. Putting here or maybe here, you will get what? It will be positive, right? -1, -2, negative, negative, positive, -1, -2, check below, -1, -1, -2, positive, positive. It's positive, right? Is it correct? Positive. And check and between 0 and 1, you can check half, 2/3, 1/3, any number that you can easily compute. Okay, it will be negative and it will be positive. Okay, so by using the vertical asymptotes, at least we are not really lost to sketch this graph. Okay, but remember, 0 and 1 is not critical point. It's the vertical asymptote. This is VA. So it's increasing and then decreasing and then increasing. And this is the asymptote. Okay, at least we get how the function increase and decrease. Okay, but we still not really finished how the functions looks like. Is it like this or like this? Then we need to check with the second derivative. Okay. Okay, from the our form here, we have the first form, the first derivative is like this, and before we combine, it's like this one, right? Do not make your life difficult. deriving this part, okay? Just making this derive and then combine, okay? So derive this part. So T double prime. So we can directly 3 to 6 is 6 over x4. It's become positive, okay? And then the positive become negative. 6, 4. If you want, uh, you can check um, whether the function is always positive or always negative. This is having an even in power here, meaning um, when you put any number here should be positive, right? This part, but depends on what we'll get. Is it always positive? Um, if you try 2, it become negative, right? It become negative. It is always bigger, right? Okay. Now we can combine these two if you want and checking whether we have inflection point or not. Okay, we have now uh, x minus 1 with the power of 4. If you want, we can expand this. Okay? But don't worry, I will not giving you this equations in exam. Okay, this is really long. But let's say we need to expand this form. Okay. Remember, you have 1, 4, 6, 4, 1 as your this is your coefficient. You can write this as 6. I will go directly to the results. Okay, so x to the 4, I will cancel both of them. So it will render 4x cubed um, minus 6x 6x squared plus 4x. Okay, and then minus 1. Divided by x to the 4th, x minus 1. 4. Okay, now we see that we have this form. Okay, 4x cubed minus 6x squared plus 4x minus 1. How to check whether this thing has a root or no? If it is quadratic, you can check the quadratic formula easily, right? But how about we have cubic formula? How to check the roots? Okay. Okay, I will show you one method. Uh, it's not always working, but mostly for any polynomial with the integer, with the root integer, it will always work. Okay. So I'll write 4x cubed. Okay. let me make this is a function of x. Okay, and I will also make the function of negative x. This will be negative, and a negative, and a negative. I also, I think I teach this also in the basic math class, but let's just see these two polynomial cubic formula. Okay? For the positive x, okay? See the signs. Okay? It's positive, negative, positive, negative. Okay? Every time the signs changing, let's say this 1, 2, 3. 3 change, right? I will write, we will have possibility or chance that we will have 3 positive roots or 1 positive root. So this is a prediction. It's called the Descartes rule. If you want to know the theorem, so it's called the Descartes rule. Okay, and in negative, it's all negative. So we are saying here we will have 0 negative root. This means we have the number of root will be 3 or 1, and the negative 1 will be 0. Okay? And let me make a table here. Because this is a cubic formula, the root should be at least three roots, right? So I will write 3 roots. Okay. The first way is we have 3. So all 3, right? So we will have 3, 0, and 0. This is imaginary. Okay? I is for imaginary number. And the other way, we will have 1 positive root. So 1 positive root, 0. And because total is 3, we need to have 2 imaginary roots. So this is how you are counting how many roots you have. Okay. And the rules say, so why this is 1 here? The rules say that if you count the sign of change, you need to subtracting with even number, a whole even number, which is 2. So if you get 5, you need to subtract 5, 3, 1, or 0. If it is 4, 4, 2, 0. If it is only 1, that's only 1. We cannot minus 2 because it will be negative. This is the counting, so we don't have negative in counting, right? So we have 3 or 1. Okay. So what's the conclusion from here? We don't have negative root. Okay. Okay. And let me write one more, the 4x cubed. So from here, from this polynomial, the idea for root is also can be seen from the last term and the first term. Okay. So factor of 1 and factor of 4. So I will write here factor of 1. Factor 1 is only positive, negative 1, right? Any number that when you multiply, it will be 1. And then factor of 4, it will have positive, negative 1. You will have at least 3. So 1, 4, 4, 2, 2, 4, right? And it can be plus minus. Okay. Now the roots, okay, the possible of roots, okay, possible of the roots. The possibility of roots is the last term divide by the first term. Okay. So it will be, because the last term is only 1, so we will have plus minus 1, plus minus half, plus minus 1 over 4. This is our possibility of root. And because we already conclude there will be no negative root, we can check. We can check. We can check positive 1. So we can check three numbers: 1, half, and 1 over 4, the positive one. Okay. Okay. How to check? If you want, you can check one by one for the functions. Or if you remember to define the functions, wait, a little bit delay. Why so slow? Okay, remember, uh, it's called the synthetic division in polynomial. So you divide with each of these three forms. If you divide 1, you can check. You will get some number here. So it's not our answer. Okay? And then divide half. Okay. Okay, we get 0. So we find our root. Okay. So this is helpful, especially if you get cubic or power of 4. Okay. It can be helpful. Okay. So you can see from here, at least you get x is half. And you can check other 1 and 1 over 4, it will be not 0. So we only have one positive 0. So the other two roots will be imaginary. And we don't really care imaginary. So we only care about the real solution. So x equal half. It's our roots. Meaning x equal half is our inflection point. So we can also checking the g double prime. So we have half, we have 0, we have 1 as our asymptotes. Okay, now we check our point 0, half, 1, check in between, and believe me, it will be positive, positive, negative, negative. So when you have positive, positive, negative, negative means the curve will be upwards, upwards, downwards, downwards. Okay? So it will be going up, going up, going down, going down. Okay? Okay, let me draw the curve based on this information. So let me make and maybe here. So this is the asymptote. It's 1. This is also asymptote is 0. And half is our inflection point. So it said that the G prime, from the G prime, before 0 is always increasing. Okay. But remember, we have also horizontal asymptote here. So meaning, because we have asymptote, the graph will be from here and then going up. So it's going up, okay? And also it's fitting this curve, okay? It's upwards. And then it's still upwards in between this 0 and half. But 0 until 1 should be going down. So we have it's going down, but still upwards, okay? Still upwards. So it's going down. And at nearby the half, it will be changing like x cube, like x cube. Okay? It's the inflection. So it's still going down, and then change to negative, meaning it will be downwards. Okay. And then after 1, it's increasing, but it's downwards, and it has the asymptote here and here, right? So like that. Okay. And it's increasing, but it's coming from below. Yeah, like that. Okay. And to show you how the graph looks like, this is how it looks like. Okay. Notice that at half here, it's not really that much different. But if you zoom in, you will see a slight inflection. It will slightly change the concavity. Okay. Okay. Yeah, this is uh, not not really a simple function, but to approach with calculus, actually we can approach with calculus. Okay. But I will not give you this complicated one in the exam. Okay, any questions first? After this part, I will move to reviewing chapter 3, giving you an example for your quiz preparation. Okay. Any questions? No? Okay. Let me check. Um, okay, let me check this one. Okay. So evaluate. So this kind of limit also it will be included in the quiz. Okay, so you get the answer? Okay, okay. You get the answer? Oh, okay. Okay, so you can check first, check 0. So if you put 0, you will get 0 over 0, right? So because we already done with the L'Hopital rule, we can just directly say that we can uh, go use L'Hopital rule, and it will be limit. So it will be 1 minus cos x, and then 1 minus secant squared x. Okay, and check 0 again. One more. Still 0, 0, right? Okay, so if you try one L'Hopital rule, you still get 0 over 0. You can try more. So L'Hopital one more. Okay, this is if you want to try L'Hopital rule. Okay, so it will be sine x, and then minus secant square will be um, minus 2 minus 2. Okay, it will be tangent x secant square x, and then if you check, and then it 0, still 0, 0, right? Maybe you want to take L'Hopital one more. So it will be cos x, and then tangent secant squared. Um, it will be minus 2 secant squared x. Should be secant squared with x uh, plus 2 tangent. Plus 2 tangent. Is that correct? Actually, I can rewrite the form. Actually, there's many ways to solve this. You can L'Hopital, and going through, if you are not really confusing about derivative, you can go through and derive the whole thing. Um, and you can always check this. And you can also change this, all this secant squared into tangent squared, and then derive. And you will eventually you will get the same result as this if you want to derive. Oh, it should be squared. Sorry. Okay. And eventually, when you are plug in your 0, you will have this will be 1, this will be 1, 1, and this 0. So it will be negative half. So this, if you want to derive directly. Okay, but if you want to change the form from here, okay, this x minus sine x and x minus sine x and x minus tangent, you can maybe multiply with x plus tangent, x plus over x plus tangent, and check whether it will be easier for you. So you can derive directly L'Hopital, 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 or you can maybe change a little bit the form and then derive after that. Or maybe you can just derive, just change the form and see whether you can simplify the form and get the answer easily. Okay. I think there's a lot of way, and in the middle part here, you can also maybe multiply with 1 plus cos x, so you have the 1 minus cos squared x. It's also possible. So there is a lot of possibilities. What I'm showing you this is just directly L'Hopital, L'Hopital, L'Hopital. Okay. You can also do this, okay? But you can also change in the middle or in the first sentence. You can change your way, okay, and simplify your answer. That's also possible. Okay, that's also possible. Okay. Okay, that's L'Hopital. And let me give you another. Um, okay, can you derive this? Should be not too difficult, right? And then also try. Um, let's try this one. I think number one is. I think it should be not too difficult, right? Can you do it? Okay. hmm Yeah, you can rewrite the form and check whether you can simplify or not. Mhm. So yeah, you can cancel, yeah, but minus. Yeah, yeah, yeah. It's correct. It's correct. But don't forget the minus. This minus. This divide this minus, right? 1 minus cos divide cos x minus 1 is minus. Right? Yeah. Hmm, jawaban. Ini kenapa di bawahnya ada Y? Ini di bawah sini. Ke atas dong sini. Hmm. Ya. Hmm. Jangan dihafalin. Nggak akan kamu nggak akan bisa kalau ngapalin. Nggak akan bisa. Jangan dihafalin. Jangan dihafalin. Nggak percaya saya nggak akan bisa. Nggak akan bisa. Nggak akan bisa. Ya ya. Hmm. Okay, so the first case is, I think it's not too difficult. You can think this is two functions, right? It's product rule. So your f prime is, let's say, derivative of the f, it will be negative 2, and then sine x, and it will be plus with uh, and then cos x. And then you will have right? Okay, not too complicated, right? I think this one also should be not really that difficult. So if you want to derive, it will be negative sine inverse x, and then you need to multiply with the inside, which is sine inverse x. Okay, and I will always writing down my functions. So if you have this theta, this is x1, and then derive this part. So it will be cos theta d theta dx 1. And see from here, cos theta is so this should be 1 over. Okay. So the answer will be minus sine inverse. It's just minus x, right? This whole thing is just minus x, right? You have sine inverse. Like if you have cos inverse x, it's x, right? Sine inverse is just x, right? It's the inverse property. Okay. So it will be minus x multiplied by 1 or negative x over this. Okay. Let me give you This one. Can you read? Sorry, my writing is not really that good. So, wait. You have a sphere. The radius is 21. Let me. Okay. So the radius is 21 with a possible error. Okay, you have error in measurement is 0.05. So you have an error here. So what is the maximum error using this value of the radius to compute the volume of sphere? So you need to compute the volume of sphere. The question, first question, do you remember volume of sphere? Remember? What is the volume of sphere? Yeah, 4 over 3 pi r cubed, right? Okay. So maybe just writing that first. Okay. But let me tell you what this question is about. Okay. So you have a measurement. So you have the volume, right? Volume of sphere. And the questions, the information said that uh, the radius already measured, it is 21 centimeter. But in the measurement, when you measure, it has an error 0.05. Okay. So another question is, how do you, what do you think this question is about? What do you think? With 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 section or with chapter? Yeah, it's chapter 3, but with which one? It's not related rate. There is no moving. There is no movement, right? But you have an error. Error. So if you heard any error, probably the error is because you are approximating something. You are approximating something. Okay. So this question is about linear approximation. It's about linear approximation. Okay. So this is a linear approximation. So imagine the volume is our function. Okay. The volume is our function. Okay. Let's derive this volume to see the function. We can write the terms in differentials. Okay. So let's derive this v become dv, and then 3. Okay. Basically similar with implicit, okay, with implicit differentiation. And you will have dv is dr. Okay. So the d is the difference. If you're going back to the linear approximation, this is actually the x minus a. This is the f fx minus fa. Okay. Let me write the linear approximations that you know is right. We can uh, solve this become this is our delta, right? Let me write this is our delta. And this is also our delta y. Okay. So actually, the delta here, we can write in terms of d. So we can write this as dy dx. And we call these terms differential. So when you derive in terms of differentials, you can derive phi uh, as your y. Okay, so it's become d phi, and the r is the x, and it's become dr. Okay? For single variable, it's quite easy to use. This differential, and you will maybe learn more about differentials in, I think, in engineering of math. Okay, most of equations will be differential equation and how to solve differential equation. Okay. Okay. Now to solve this, we need to check what is 21 and 0.05 means. Okay. So the radius. Let me write the radius. So radius is 21. Okay. The error is 0.05. The error. Okay. So error is our dr, right? So we can, uh, yeah. So volume will be 4/3. Let me, how many minutes we have? Maybe I can give you another questions. Okay, maybe we'll have more questions after this. Um, so because the R is 0.05, we will have maximum error. So the maximum error for volume, this will be maximum error because it will be having the difference between our approximations and uh, the real number there. Okay, so we say this will be the maximum error we get from the function. Okay, this is the error from the measurement dr. Okay, so we check the number inside. It will render. This will be, yeah, oh, 4 pi. Sorry, and you can count uh, what is the number. I haven't counted yet. Yeah, so yeah, that will be that your maximum error. If you are asked, okay, relative error. If you are asked in the questions, delay or relative error, how do you compute relative error? Okay, relative error means you have dv, okay, uh, that one, right? You have dv and you have v. The error means is your delta over the function itself. Okay? Imagine the function is the volume of sphere, okay, and your approximation is the derivatives of that volume. So we can write dv. But let's wait until it. So we can write this is dv over v. Okay. And we can, oh sorry, this is 4. So dv is 4 pi r squared dr, and v is 4 over 3 p pi r cubed. Okay, and solve this, and we get it will be 3 over r dr. And check with the our number should be, yeah, and this will be your relative error. It's around 5 over 700. And from relative error, you can know the percentage of error. You just need to make 5 over 700 become the percentage. So 5 over 7%. Okay. There's some additional notes for linear approximations. Okay. Can you try this one? Uh, so there's a parabola, ax squared plus bx plus c. It's passing 1.1 and 4, 1, 4. Okay. And the tangent lines, when x is -1 and x is 5, it's having slope 6 and -2. And you need to find a, b, c, the parabola. Okay, first the parabola is, we already know the form, and from this parabola we can get the derivative, which is 2ax plus b. Okay. So we need this derivative, okay, this y prime, because we know the tangent line. If x is -1, it will have the slope is 6, right? So we can use that. So at x equal -1, it will be 2 -2a plus b equals 6, and at x equal 5, it's 2, 5, 10. is -2. And then you can solve this a and b. So you get a is -2/3. And then just using that informations. Uh, so 4/3 plus b should be 6. So b is 14. And then we have point. So at point 1, 4. So meaning we have 4, or I will write the whole equation. So y ax squared plus bx plus c. So this is 4, and a is -2/3, x is 1, plus 14, 3, 1 plus c. Okay, so we have 4, um, it's 12, 3 plus c. So c will be 4 minus 12/3. So this is basically 0, right? So your equations will be y okay, a little bit delay. So your equation is just only having -2/3 x squared plus 14/3 x. Okay, now oh, still waiting. Okay, any questions first? Any questions? Why it's so long? Yeah, slope means the gradient. The gradient. How steep the gradient. Let me restart this program. Okay, this is okay. Try this one. Uh, Probably I don't have really much time to solve it, but check this out. You have the parabola. Inside the parabola, you have a circle. The circle have the radius 1. The parabola is y equal to x squared. You need to find the center of this circle C. So this point, and then P and Q. Okay, the idea is first you have the parabola to x squared. And at this P and Q, imagine you have a tangent line there. So find the tangent here. And this PC and QC, you can get just by the distance equation. Because the distance is 1, right? You get the distance equation. So y minus y1 minus y2 squared, y x1 minus x2 squared, right? The distance. Because it's only 1, then uh, you can uh, evaluate uh, the point. Okay? But the first thing you need to do is maybe from this graph, okay? Maybe you check P and Q with some A, B, okay? Some points, okay? Maybe P is A and the functions is 2x squared, A to A squared, and maybe Q is B to B squared. That will help you find, okay? And the C is just, let's say just 0C because it's on 0 and it has C at Y axis, right? So maybe you can write this as A and 2A squared, okay? And this is B and 2B squared. And it's just 0C, right? Okay, now because I already mentioned about distance, let's write the distance equation. Okay? So 1 squared equal okay. I just write this first and keep that. Maybe write down this as the first equation we get. Okay. And then we check the equation y equal to x squared. Okay. To observe our point P and Q, we can observe the tangent. Okay. So let's derive this, become 4x. Okay. So 4x will be the tangent. Okay. And then from this P and Q here, if you have the radius, okay, you will have at some point the P and the straight line tangent line here is become a normal here. Okay, so let's write um, the normal line. The normal gradient will be negative 1 over 4x. Okay. Now we have 2 points, right? At least 2 points here and also here. So we can write linear equation. Let's say at A. Okay, let's say at A. So y minus 2a squared and we get linear equations x, right? And then plus 2a squared plus 1 over 4. Or we can also write this as in mx plus c, right? Okay, let me make it bigger. Okay, and now we also know that the c, the point c is 0, c, right? So when x 0, y is c, right? Y should be c. Okay, so c of 0 is 2a squared plus 1 over 4. Okay, so when x is 0 and y is c, c is 2a squared plus 1 over 4. So you get point c, the from the equations. Okay. But we still have a in the equations, right? So let's write this as our equations too. So we have 2 equations. So first is the distance equation, and the second one is the linear equations at the 0 and c. Okay? And we can combine these two. So combine 1 and 2. Okay? So 1, we change the c into this 2a squared plus 4. A squared. Okay? And then plus a squared. And we get actually 1, this is 1 over 16 plus a squared. So you will have a is a squared 1 minus 1 over 16. So a squared is 15 over 16. Or you can say that your a is plus minus. And notice that because of the symmetric, okay, this other minus will be the b. Okay. So I will write a is the positive 1 and b is the negative 1. and we already found A, then we can go to the equation 2 and bring back this 15 over 16 here, solve the C. So C will be 2, so it will be what? Uh, 15, 16, 34. 34, right? 34, 16. Yeah, yeah. So you get A, B, and C. Okay. So any questions? Any questions? No? Okay. I think that's all for today. Okay. And don't forget Thursday quiz. Okay. Okay. If there's no questions, then uh, that's all for today.